Hi, we're probably at the video you've been waiting for, constructing a box plot by hand. This is another video from the 5-number summary and box plots. And in this one, we're going to construct the box plot and by hand in this video, and a follow-up video will actually do it in Minitab. To calculate or to construct the box plot, we need the 5 numbers from the 5-number summary. So the numbers that we've already figured out how to determine are the first quartile, which is Q1, the third quartile is Q3, and these are going to become the bottom and top of the box. So we're making this box with the bottom with a line at Q1 and the top at a line at Q3. Now the median to Q2 we're going to indicate by a line through the box at position Q2, and this line is parallel to Q1 and Q3. Now the whiskers, and I've been a little bit mysterious about this limit. The whisker, the lower whisker, we're going to start at Q1, and then we're going to go to the smallest value within the data set that's in some limit. So we'll talk in a minute about how we find those limits, but right now I have a whisker that extends from Q1 down to the last data value that's within a reasonable distance from Q1. And then in the same way, we have an upper whisker. We start at Q3 and we draw a line to the largest data value that falls within this upper limit. So the limits, they're also called fences, are some people use dotted lines to draw them in a box plot. They're kind of cutoff values that say if you're beyond this value, this value then is if you're beyond a fence, this value is somewhat unusual or unexpected, and that's when we denote it as an outlier with an asterisk. So the way that we compute this fence, the lower fence, we take Q1 and we subtract off 1.5 times the interquartile range, which, as you recall, the interquartile range is Q3 minus Q1. And similarly, the upper limit or the upper fence, we take Q3 and we add to it 1.5 times the IQR. And again, we might denote this with a dotted line, but any value that would go beyond this fence is unusual, and we call it an outlier, and we'll denote it with the asterisk. We're going to go ahead and go through 2 examples of box plots. I'm not going to talk in depth about how we get the 5-number summary because we've done that in previous videos. So you can go back and verify the numbers that I tell you are correct for the quartiles, but I'm kind of just going to buzz past those. This data set here, it sounds kind of funny the way I wrote it, but these are 50 times in minutes that the times are times it took me to fall asleep when I went to bed reading a book. Hopefully not the same book every time, but imagine you might do this yourself. When I can't sleep, sometimes I grab a book, and so I was just tracking the number of minutes I read the book until I fall asleep. So I ordered these data values from minimum to maximum. I mean, this is not the way I can, I didn't what do you want to say? I didn't gather them in this order, but I ordered them to make this example a little bit easier to see where the quartiles are. So here are 50 times their minutes it took me to fall asleep while I was reading a book before bedtime. So here's minimum to maximum. There are 50 data values. And let's just pull the data in. By the 5-number summary, it's pretty obvious. The minimum is 8, the maximum is 23. The second quartile is in position 25.5. So if we go between the 25th and 26th data point and we average them, we get Q2 is 15 minutes. Q1 is in position 12.75, it's 12 minutes, and Q3 is in position 38.25, and it's 17 minutes. And if you need to review how these values were obtained, they were in previous videos that contain the by hand calculations for the 5-number summary. So here's the new part for us is calculating the fences. So the lower fence is at position, or not at position, but at the value 4.5. How we're computing the lower fence is we take the value Q1 and we subtract off 1.5 times the interquartile range, and we get 4.5 minutes. So the lower fence is that cutoff value that says if there's anybody below 4.5, they're unusual and will be denoted with the asterisk. The upper fence is started at Q3, and we add to it 1.5 times the interquartile range and get 24.5. So in the same way, we have this invisible, or you could draw in a dotted line, a fence at 24.5. If we have any data values beyond this, we say that they're unusual, and we'll denote them again with an asterisk. So I went ahead and drew this. I drew it by hand, but then I did it in Minitab, so it looks nicer than I would have done. There's no data values that are beyond the fence. There's no data value that's less than 4.5, and there's no data value that's greater than 24.5. So I make the box with the upper part of the box is Q3, the lower is Q1. Right here we have the median at Q2, which is 15. The upper whisker is the maximum data value that's within the upper fence. So it's going to be actually the maximum in this case. So if we go back to our data set, this is the largest data value that we have, and this is actually the minimum of the data set. We have, again, a fence at 4.5, but there's no data points that go beyond that. So our lower whisker goes to the last data point within that lower fence, and the upper whisker goes to the largest data point that's still within that fence. And in this case, they turn out to be the minimum and maximum. So I went ahead and did another graph because we didn't see any outliers in this graph, and I wanted to at least be a little bit more clear how these fences work. I took a random sample of 26 lakes in Pennsylvania, and we chose those to determine their pesticide contamination levels in parts per million. So again, I have a data set in parts per million, and I've already ordered it from minimum to maximum. So again, that ordering is so important, but I've done it in all these examples just to move us along. So the 5-number summary, the minimum definitely is 30. I can't believe I didn't put the maximum here, but it's 511. The second quartile is in position 13.5, it's 119. First quartile position 6.75, it's 83. Third quartile position 20.25, and it's 182.25. So here are our fences. I start at Q1 and I subtract off 1.5 times the interquartile range, which is just again Q3 minus Q1. And we get a negative value, but realistically we can't have a negative parts per million, so we can go ahead and reset the lower fence at 0. I mean, we want it to be practical. The upper fence is at the Q3 plus 1.5 times the IQR, which is 99.25, and this is where our upper fence would sit. So as you notice, the data value 511 is beyond that upper fence, so we would say that's unusual and denoted as an outlier. And 291 is actually the largest data value that's within this upper fence. So our upper whisker is going to extend to 291. The lower fence is at 0, and as you can see, there are no data points below 0. 30 is our minimum, so our lower whisker is going to extend to 30. So I think for my students, a lot of them get confused about where the lower or upper whisker stops, and those whiskers don't go to the fences, they go to the last data point within the fence. So be careful that your students aren't saying, oh, I'm just going to extend this to the fences. The fences are just ways to be able to determine if one of our points is out of line with the others. So let's go back up here and look at the graph that I created. So here's Q1, Q2, Q3. They're making the box for us. If we subtract Q1 from Q3, we get the interquartile range. The lower whisker it goes down to the minimum data point that's within the lower fence. And the lower fence, you know, we can sketch it right in here, was at 0. And there are no data points below 0. So the lower whisker extends to 30. And the upper whisker extends to the last data point within the upper fence. And so again, I just denoted with a dotted line here. Minitab doesn't have this dotted line. I added it just to show you again where that cutoff is. So the last data value within that upper fence is 291. So this upper whisker stops at 291. And we have this one value, 511, that went beyond the upper fence, and we denote it with an asterisk as an outlier. So I hope these two examples have helped. I mean, this is all, I hope you see how it's all coming together nicely. We have this 5-number summary. We put it into a box plot. We can tell, you know, if we have outliers, we can use the position of Q2 in the box to tell us a little bit about the skewness. So again, I think this is a very special graph, and it's one you want to know because you will see, you know, you will see it coming up in scientific literature, and especially, you know, yeah, well, in statistics and just popular text as a way of trying to show the shape of the data and some of the important parts about the data set. So in the next video, what we'll go ahead and do is compute the box plot using Minitab. So we've done it by hand, and I think it helps explain all the pieces. And now we're going to go to Minitab, which will nicely calculate all these values and just output a beautiful box plot all at once. And so that's our next step, and that's our next video. So until then, I'll just wait to talk to you more about that, and I'll be seeing you soon or talking to you soon. All right, thanks.